Open your book to page 54, and this is lesson 2.6. This lesson is on prime factorization. Okay, so a prime number has two factors. And another term you need to know is the composite number. So composite number has more than two factors. So for example, so here are the prime numbers. So prime numbers are 2, 3, 5, 7, 11, okay, 13. So here are some of the prime numbers. Because the prime number can only divide it by, the factors are 1 and 2, and this is 1 and 3. And notice all the prime number has a factor of 1 in itself, right? 1 and 5, 1 and 7, and 1 and 11. And this is 1 and 13, right? And so forth. Again, there are more, right? Now, example composite. So example of that would be 4, because 4 can divide by 1, can divide by 2, can divide by 4, right? And 6, you can divide by 1, divide by 2, divide by 3, divide by 6, right? So you have more than 2 factors possible. Factoring means what you can divide it by, okay? And then you have the 8 is 1, 2, 4, 8, right? Again, so these are the example of composite numbers. Okay. Now, how about 1? Well, 1 is neither. Okay, so 1 is neither. Okay, so because 1 can only divide by 1, so it's not. So 1 is not prime and it's not composite. So it's neither. So when you look at the numbers, you kind of have to start with 2. Okay, so again, 1 is neither. Okay, so now let's go and do the prime factorization. So on page 55, prime factorization means you want to break down a number into prime factors. So let's go to example 2. So example 2a, you want to find the prime factorization of 30. So 30, and what you want to do is you want to use, this is called a ladder method, because it looks like a ladder. So what you do is make it like an L, and you can divide by prime numbers, or only use prime number because you're looking for prime factorization, right? And so what you want to do, you want to start, and notice you have the list over here. So here's your prime numbers. So usually you kind of just start with 2, and then 3, then 5, and 7, and keep going, okay? So divide by 2. So this is like upside down division. So 30 divided by 2, you get 15. And you want to keep trying. If you can divide, you keep going until you cannot, right? So try it again, 2 cannot, right? So divide by 3, you get 5. Okay, so the prime factorization would be 30 is equal to 2 times 3 times 5. So in other words, 30 is made out of these 3 factors. So that's what the prime factorization means. It means you want to break a number down into its prime factors. Okay, now let's go to 2b. 2b, you want to do 20. So 20, again, you divide by 2. Again, you try to start with 2, 3, and 5 and go up. Okay? So don't go all over the place. Try to keep it organized. So divide by 2, you get 10. Divide by 2, you get 5. So 20 equal to 2 squared times 5, right? There are 2 of them, right? So 2 squared times 5. So again, so that's your prime factorization. Okay, so let's go to 2c, 36. So you can start with 2, divide by 2, you get 18. Divide by 2, you get 9. So 2 cannot, so you go on to the next prime number, 3, right? So 36 equal to 2 squared times 3 squared. So again, there are 2 of them, that's what square means. There are 2 of them, that's what square means. Okay. And so that's 2C. Now let's go to 2D. 2D, you're looking for prime factorization of 315. So again, you start with 2, so cannot. So you go to the next one, so 3. Now 3, to find if you can divide by 3, you add all the digits together and see if you can divide by 3. So if you add all this together, you get 9, right? 3 plus 1 plus 5 get 9. And 9 can divide by 3. So that means that's how you know that you can divide by 3. So divide by 3, you get 1, 0, 5. Now this can divide by 3 again, because if you add all the digits, you get 6. And 6 can divide by 3, right? So divide by 3, you get 3, 5. So now can this divide by 3? No, right? Because 3 plus 5 is 8, and 8 cannot divide by 3, right? So you go to the next prime number, right? So the prime numbers are 2, 3, the next one is 5, right? So divide by 5, you get 7. And so that's it. So 315 equal to 3 squared times 5 times 7. So again, 315 is made out of these 4 factors. Okay, let's go to example 3. So page 56, example 3, you have 97. And so again, you try, so you want to try, so if you try 2, cannot, 3, no, 5, and then 7, cannot, 9, cannot. And after that, you don't need to try anymore because 9, if you 9 square will give you 81. So what you do is, you want to see, if you want to find a 2 number that multiply and it's less than that. So when you go 11 times 11 is 121 or it's exceed that. So nothing can divide by that. So in this case, this is a prime. Okay, so 97 is a prime. Okay, the next thing we need to do is go and do the test of divisibility. Okay, so a number can divisible by 2. A number can divide by 2 if it's the last digit is even. So if the last digit is even, then you can divide by 2. Now, for divide by 3, you add all the digits together. And then after you divide by 3. Okay, so again, you add all the digits together and divide by 3. Then if it can divide, then yes. If it cannot divide, then it's no. Okay. And divisible by 5. Okay, the last digit, in order to divisible by 5, to divide it by 5, the last digit must be equal to 0 or 5. Right, the last digit has to equal to 0 or 5 in order to divide by 5. So these are how you test what can divide. And there are other things, but we're not going to cover it over here. Okay, so that's how you figure out what a number can divide by.